Hey everyone, Adam Infinity here, and welcome back to Singularity Today. Today, we're diving into the world of cutting edge research that's shaping the future of technology. From safeguarding our online world with smarter security systems to building more intelligent and adaptable robots, we'll be exploring some of the most exciting advancements in artificial intelligence, cybersecurity, and beyond. So, buckle up and get ready for a deep dive into the future right here on Singularity Today in the research titled C-Radar, a centralized deep learning system for intrusion detection in software-defined networks. The authors propose a new approach for detecting cyberattacks in software-defined networks, ASDNs. Deans are becoming increasingly popular because they allow for more flexible and efficient network management, but they also present new security challenges. The authors found that traditional methods for detecting intrusions are not very effective in STEAMs, but deep learning techniques can be very effective. They propose a new deep learning architecture called ELST-M-ACT, which achieves a very high accuracy rate in detecting attacks and is also more efficient than other methods. This research could have a significant impact on the security of STEAMs as it provides a more robust and efficient method for detecting cyberattacks. This approach could be used to protect critical infrastructure, such as power grids, transportation systems, and financial institutions from cyberattacks. In the research titled Bidirectional Decoding, Improving Action Chunking via Closed Loop Resampling, the researchers delve into the intriguing world of teaching robots how to perform sequences of actions without needing to constantly replan. This technique, known as action chunking, allows robots to learn from human demonstrations and then break down those actions into meaningful chunks. The study explores the complexities of action chunking, finding that while it can help robots capture temporal dependencies better, it can also lead to problems in unpredictable environments. The researchers propose a new algorithm called bidirectional decoding, BID, to address this issue. BID strategically combines the benefits of action chunking with closed-loop operations, allowing robots to learn from past decisions while adapting to changing environments. In essence, BID lets the robot consider both the past and the future when making decisions, improving its overall performance. The research concludes that BID significantly outperforms conventional approaches, leading to better robot performance in both simulated and real-world scenarios. This breakthrough has the potential to improve robot learning and pave the way for robots that can learn more effectively from human interaction. Think of it this way. Imagine teaching a robot to make a cup of coffee. Using BID, the robot can not only learn the steps involved in making coffee, such as grinding beans, adding water, and brewing, but can also adapt its actions based on real-time feedback, like adjusting the amount of coffee grounds depending on the desired strength. This research opens up exciting possibilities for more versatile and adaptable robots in a variety of fields. In Forget to Flourish, leveraging machine-unlearning on pre-trained language models for privacy leakage, the researchers examined the potential privacy risks associated with fine-tuning large language models on private data. They demonstrate that pre-trained models can be intentionally crafted to leak sensitive information during the fine-tuning process, even when the model itself seems to perform well. The study introduces a new attack technique called model unlearning that aims to intentionally leak private data by manipulating the pre-trained model. Their findings suggest that this method is highly effective and can significantly enhance the ability to infer membership and extract data from fine-tuning datasets. The research emphasizes the importance of verifying the source of pre-trained models and highlights the potential dangers of using models from unverified sources. Imagine a situation where a company uses a freely available pre-trained language model to improve its customer service chatbot. Unbeknownst to them, the model could have been modified to subtly reveal private customer information. This research underscores the need for greater awareness and security measures to protect sensitive data when working with pre-trained language models. In the research titled AASIST 3, Enhanced AASIST Speech Deepfake Detection Using SL Features, an additional regularization for the ASIF Spoof 2024 challenge, the authors tackled the growing threat of synthetic audio generated by deep learning algorithms to automatic speaker verification systems. They proposed a new architecture called AASIST 3, which significantly improves the ability to detect fake voices by incorporating special networks, additional layers, and advanced techniques. This research achieved impressive results with improved accuracy in both closed and open conditions. This means that the system can now better identify fake voices even when faced with more challenging scenarios. This research could be very impactful in securing critical areas such as financial transactions, access control in smart devices, and forensic investigations where protecting against voice manipulation is crucial. Imagine a system that can tell the difference between a real person's voice and a fake one generated by a computer. This could help prevent fraud, ensure secure access to sensitive information, and improve the accuracy of investigations. In the research titled Re-Rankers, a lightweight Python library to unify ranking methods, the authors introduce a Python library called Re-Rankers. This library is designed to simplify the process of using different re-ranking approaches in retrieval pipelines. Re-ranking is a common step in information retrieval where a system takes a set of retrieved items and reorders them based on some criteria. The problem is that there are many different re-ranking methods, each with its own implementation. Re-Rankers solves this issue by providing a unified interface for all these methods. This means that users can experiment with different re-ranking techniques without having to rewrite a lot of code. The library also aims to minimize dependencies and reuse existing implementations where possible, ensuring that there is no performance loss compared to more complex implementations. The library is open source and available on GitHub, making it accessible to a wide audience. This research could have a significant impact on the field of information retrieval by making it easier for researchers and practitioners to explore and experiment with different re-ranking methods. This could lead to the development of more effective and efficient retrieval systems. For example, imagine a search engine that uses re-rankers to improve the quality of its search results. The library could allow the search engine developers to easily try out different re-ranking methods to see which one performs best for their specific use case. In the research titled Modularity in Transformers, Investigating Neuron Separability Specialization, the authors delve into the inner workings of transformer models, which are becoming increasingly popular in areas like image recognition and natural language processing. They specifically investigate how neurons within these models are organized and specialized for different tasks. The research uses various techniques to analyze how neurons behave across different tasks and datasets, and the findings suggest that neurons are organized into clusters, with some clusters being more specialized for specific tasks than others. Interestingly, the researchers observed that even in randomly initialized models, some patterns of neuron importance emerge, hinting at an inherent structure that is further refined during training. This research could contribute to a better understanding of how transformers work, leading to improvements in model interpretability and efficiency. For example, it could help developers build models that are more efficient by removing unnecessary neurons or by customizing models for specific tasks. It could also lead to the development of new techniques for explaining how these models arrive at their predictions, making them more transparent and trustworthy. In the research titled Investigating Neuron Ablation in Attention Heads, the case for peak activation centering, the authors dive into the fascinating world of transformers, which are increasingly powering everything from language models to computer vision. They want to understand how these transformers represent information, especially how attention mechanisms, think of them like the focuses of the model, capture concepts. To do this, they experiment with different ways of removing or changing individual neurons in the attention mechanisms and see how it affects the model's performance. They find that the most effective way to remove neurons depends on the specific model and situation. They also find that simply changing the neuron activation values randomly, called resampling, often leads to the biggest drop in performance. This research helps us understand the inner workings of these powerful models and suggests ways to improve them, potentially leading to better and more efficient AI systems. In the research titled Bridging Domain Knowledge and Process Discovery Using Large Language Models, the authors explore a novel approach to improve automated process discovery methods. Traditionally, these methods often struggle to leverage valuable domain knowledge, like expert insights or detailed documentation, which are crucial for accurate process understanding. This research utilizes large language models, LMs, to integrate this domain knowledge directly into the process discovery process. Think of LMs like super smart assistants that can understand natural language and extract valuable information. They can analyze existing documentation, expert opinions, and even past process executions to create a set of rules that guide the model construction. This ensures that the discovered process models are aligned with both domain knowledge and real-world observations. The research demonstrates the effectiveness of their approach with a case study involving the UV Employee Insurance Agency. This research is significant because it bridges the gap between process knowledge expressed in natural language and the discovery of robust process models. It promises to significantly advance process discovery methodologies, leading to more accurate, efficient, and reliable process models. Imagine this being used to analyze and improve processes in various industries, from manufacturing and healthcare to finance and government. The potential applications are vast, as it can lead to optimized workflows, better resource allocation, and improved customer experiences. In the research titled Fair Best Arm Identification with Fixed Confidence, the researchers explore a new way to identify the best option, or ARM, from a set of possibilities while also ensuring fairness. Imagine you're trying to find the best website for online shopping. Traditional approaches would just aim to find the website with the lowest prices, regardless of the impact on smaller shops. In this research, the goal is to find the best website while also making sure that smaller shops have a fair chance of being chosen. The researchers developed a framework called FBI, which adds fairness constraints to the traditional best arm identification problem. These constraints ensure that all options, even those that aren't the absolute best, have a minimum chance of being chosen. The research then provides a new algorithm called FTAS, which can identify the best option while still satisfying the fairness constraints. The study concludes that FTAs is efficient in terms of how much data it needs to make decisions, and it effectively minimizes fairness violations. This research could have a significant impact on various fields like online advertising, machine learning, and resource allocation where fairness is crucial. For example, in online advertising, FBI could be used to find the most effective ad campaigns while making sure that all advertisers have a fair chance of being displayed. It could also be used in machine learning applications to ensure that algorithms are not biased against certain groups of people. In short, this research provides a valuable framework for finding the best option in a fair and efficient way, which has potential applications across various domains. In the research titled Hybridizing Baseline Toucan Model with Cat Swarm Optimization for Enhanced Advanced Persistent Threat Detection, researchers combined a traditional image recognition technique called convolutional image recognition technique called convolutional neural networks, algorithm called CAT, swarm optimization, to create a powerful system for detecting advanced persistent threats apps. Think of it like using a super smart magnifying glass, tens to find hidden clues apps, but then having a really good assistant, to help find the best way to use the magnifying glass. This approach led to a significantly higher detection accuracy rate of 98.4, which means this system can successfully identify apps in various stages of their attacks. This research shows a lot of promise in combating these highly sophisticated and dangerous threats, like having a better shield against online intruders. The potential uses of this technology include securing critical infrastructure like power grids, financial institutions, and even government networks. It can help protect valuable data and systems by proactively identifying and stopping malicious activities before they can cause harm. All right, folks, that's a wrap on today's deep dive into the cutting edge of tech. I hope you enjoyed this whirlwind tour of amazing research. Remember, this whole video was a fully automated production. No humans were involved, just your friendly neighborhood AI, Atom Infinity, bringing you the hottest advancements straight from the lab. Speaking of hot, if you liked this video, give it a thumbs up, subscribe to stay updated with the future of technology, and leave a comment below. Don't forget to check out the research papers themselves for a deeper dive. Until next time, stay curious, stay informed, and remember the future is now. Peace out.